Hello everyone, today I'm going to teach you how to draw dilations in the coordinate plane, and I will also show you how to verify that this shape is similar to the original shape. First, for a dilation in the coordinate plane, I want you to know that we are dilating around the origin, and it makes it pretty easy because all we need to do is multiply the x and the y coordinates of every point by the scale factor, which is sometimes called k. So given this quadrilateral JKLM and its vertices, I already graphed the points given to me and labeled them. Now I need to graph the image of it after a dilation centered at the origin with a scale factor of 2.5. We have already discovered that a scale factor greater than 1 will be an enlargement, and let's take a look at how that will work. So for this, the image of J, we are going to take the x value and the y value and multiply each of them by 2.5. So on this one, we get -5, comma, -10. So I know that the image of J will be at the point -5, -10. Oh, sorry, that should be +10. I was wondering why that didn't look right. There we go. Next, for the image of K, we'll do the same thing. -2 times 2.5 is -5. And again, -2 times 2.5 is -5. So the image of K is at -5, -5. Next, we have the image of L. -4 times 2.5 is -10. -2 times 2.5 is -5. Finally, for the image of M, I'll follow the same steps. Multiply the x and the y coordinate, each by the scale factor, to find the image of the point. Finally, I can connect each of these coordinates to create my image. I want you to pause this video and try this practice problem below. This one is going to be a reduction. Here's what that should look like. Now remember, this original shape, the pre-image and the image, are similar figures. That means, remember from our previous lesson, that they have all the same angles, they are all congruent corresponding angles, but the sides are not necessarily the same length. The sides are proportional. So they all have the same ratio. So with that in mind, remember, similarity means same shape, corresponding angles are all congruent, not necessarily the same sides. The sides are only in proportion. So let me show you how to verify similarity after a dilation. First, I will graph the original and the image. Now, in order to verify that the dilation is a similarity transformation, I need to verify that it has the same angles. So I would look mainly at the slopes here. I know that those are right angles because it's a horizontal and a vertical. Next, by looking at this horizontal, xz, meeting the slope of xy, which is a slope of, let's see, we're going up 1, 2, 3, 4 units, and over 1, 2, 3, 4, 5, 6 units. And I'm going to also look at this slope from A to B. The rise is 1, 2, 3, 4, 5, 6, while the run is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the same slope. 4 over 6, rise over run, is the same fraction as 6 over 9. Those both reduce to 2/3. So both xy and AB have a slope of 2/3. So I know that when it meets a horizontal, that's going to be the same angle. Similarly, when it meets a vertical line, these two, angle Y and angle B, are going to be the same angle. Okay, I also should verify that the sides are in proportion. So this one's a little bit easier because I have some horizontal and vertical sides. And I'm going to look here. So I have BC is corresponding to YZ. So I'm going to pair those up. I'm going to keep triangle ABC in the numerator and triangle XYZ in the denominator. You can pick either way, but you just have to stay consistent. The length of BC is 6 units. The length of YZ is 4 units. That can reduce to 3/2. Let's check another pair of corresponding sides. AC corresponds to XZ. Again, I'm keeping triangle ABC in the numerator, triangle XYZ in the denominator. The length of segment AC is 9, segment XZ is 6. That reduces to 3/2. Finally, AB corresponds to XY. Now these will be a little more difficult to find the lengths because they are a diagonal line, not a vertical or horizontal, but we can use Pythagorean theorem. I already have these triangles set up here. AB is going to be 6 squared plus 9 squared equals AB squared. So I'll take the square root of 6 squared plus 9 squared. XY is going to be the square root of 4 squared plus 6 squared. So I'll simplify that. 6 squared is 36. 9 squared is 81. Add them together, I get 117. 4 squared is 16. Again, 6 squared is 36. That gives me 52. Now when you have two square roots that are in a fraction like this, you can combine them into one square root. Now we can reduce 117 divided by 52 is what I would type into my calculator to check how this reduces, and then change it to a fraction. This reduces to 9/4. Now I know the square root of 9 is 3 and the square root of 4 is 2. I can break it back down into two separate square roots to make it easier. And I get 3/2. This proportion matches for all three corresponding sides. Since the proportions are all the same, it means that we have verified that this is a similarity transformation. All sides are proportional. Another hint for you is to look at the coordinates. Sometimes it will be easy to tell what the scale factor was. In this case, to get from 3 to 2, we would have to multiply by 2/3. So if you look at every coordinate, -6 times 2/3 gives you -4. -3 times 2/3 gives you -2, and so on and so forth. Every coordinate is multiplied by the same scale factor, 2/3. Sometimes that will be an easier number to figure out than others. This one was a little trickier. All right, I want you to pause the video and just pick 1 or 2 practice problems on the next page to complete. Here's the correct answer for A if you picked this one. This was definitely the most challenging. All the corresponding sides have a proportion of either 1/2 or 2/1, depending on how you looked at it, what you chose to put in your numerator or denominator. For example 3 practice problem B, depending on how you looked at it, again, it's either 1/2 or 2/1 as the proportion, and they're all corresponding. All the corresponding sides have that same proportion, so that one's verified. And finally, for part C, depending on how you look at it, again, we get 2/1 or 1/2, so all the corresponding sides are proportional, and it's verified that those are similar. All right, I want you to think about this. Be careful with this order, okay? It says MNOP is a dilation of ABCD. How is the scale factor of the dilation related to the similarity ratio of ABCD to MNOP. So make sure you do it in this order, ABCD to MNOP, all right? Explain your reasoning in 1 to 2 complete sentences. All right, we will be back again soon with another lesson about similar triangles. Talk to you then.